1.6 IBM's directory-enabled offerings. Many of IBM's products are directory-enabled in one way or another. Some products have their own LDAP server component, that is, they can respond to queries from LDAP clients. Some products require that an LDAP directory exists for them to work at all. And finally, some products optionally can take advantage of a LDAP-based directory service. IBM Temporary Directory Server, ITDS. ITDS is IBM's LDAP version 3 directory offering. ITDS implements the Internet Engineering Task Force IETF LDAP version 3 specifications. It also includes enhancements added by IBM in functional and performance areas. This version uses IBM DB2 as the backend store to provide per LDAP operation transaction integrity, high performance operations, and online backup and restore capability. ITDS interoperates with IETF LDAP version 3 based clients. Please refer to Chapter 4, IBM Temporary Directory Server Overview on page 83 for a more detailed overview of ITDS. IBM Lotus Domino is an enterprise-class messaging and collaboration system designed to take full advantage of the e-business revolution. It runs on a variety of different hardware platforms and operating systems. IBM Lotus Domino Server supports industry standards like Simple Mail Transfer Protocol, Simple Mail Transfer Protocol Multipurpose Internet Mail Extensions, MIME, Post Office Protocol, POP3, LDAP, and SSL. IBM Lotus Domino is designed to simplify integration into a multi-directory environment. With IBM Lotus Domino 6 or later, you have the option of moving from a distributed directory architecture, making Domino the central directory. This allows you to take advantage of a centralized directory configuration that provides added control and less overhead and is easier to manage. Domino Server comes with the Domino Upgrade Services tool. This tool is used to import users from a server-based foreign directory and register those users in the Domino directory. Domino Upgrade Services migrates data from many different systems, some of which include LDAP data interchange. Format: LDIF files. LDAP compliant foreign directories such as IBM Temporary Directory Server, Microsoft Windows NT Server, and Microsoft Active Directory. IBM Lotus Domino 6.5 also has enhanced the implementation of LDAP capabilities and improved the performance of LDAP directory access. The new Domino LDAP schema database allows you to maintain and extend schema. Other directory schemas can be imported via LDIF files. Other Domino RF6 features include support for X.500 naming conventions, including hierarchical naming and extensible attributes, for maximum flexibility in configuring the namespace. LDAP protocol support on both the client and the server, providing lookup, read, and add, delete, and modify. Write support for non-nodes clients, for example web browsers and servers. Rule-based domain relationships for faster lookups across large namespaces. Hierarchical naming and trust between domains to support the relationship of entries across domains. Supports public key infrastructure. A dynamically extensible directory schema ideal for customizing the directory to meet specific business requirements. Multi-master replication and key elements reliable directory synchronization and maximum availability. The LDAP server schema support for LDAP RFCs 2252, 2256, 2798, 2247, 2739, 2079, 1774. The new Domino LDAP schema, database schema, and SF use the tool for maintaining and extending this schema. An automatic schema maintenance process, true object class inheritance, faster schema loading, and support for the naming context, operational attribute defined in LDAP standard RFC 2251. An open standards architecture that can easily incorporate support for emerging standards. IBM Temporary Directory Integrator, ITDI. With the version 5.2 release of ITDI now has the capability via its LDAP event handler to act as a pseudo LDAP directory server and handle the LDAP transactions for various LDAP-enabled clients, while ITDI is primarily a method directory data synchronization product. The ability to act as an LDAP server can be very useful in many integration scenarios. ITDI synchronizes identity data residing in directories, databases, collaborative systems, applications used for human resources, customer relationship management, and enterprise resource planning, and other corporate applications. By serving as a flexible synchronization layer between the company's identity structure and the application sources of identity data, ITDI eliminates the need for a centralized data store. For those enterprises who do choose to deploy an enterprise directory solution, ITDI can help ease the process by connecting to the identity data from the various repositories throughout the organization. Please refer to Appendix B, Directory Integration, IBM Directory Integrator on page 681 for more information about ITDI. IBM software products that require directory. These are IBM Tivoli Access Manager, IBM Tivoli Identity Manager, IBM Tivoli Privacy Manager, IBM WebSphere Portal Server, IBM Lotus Same Time Server, IBM software products that can take advantage of a directory. These are IBM WebSphere Application Server, IBM DB2 Universal Database, IBM Lotus Notes Clients. 1.7 Directory resources on the web. OpenLDAP is a very active open source LDAP version 3 directory server and associated client tools, project that has been around since 1998. It is derived from the original University of Michigan SLAPD server. The OpenLDAP suite includes standalone LDAP server, SLAPD, standalone LDAP replication server, SLURPD, libraries implementing the LDAP protocol, utilities, tools, and sample clients. The OpenLDAP site is also the home of the GLDAP, Java LDAP class libraries, and the GDBC-LDAP, LDAP bridge driver. http://www.openldap.org. The Apache Directory project is an open source project that is developing an embeddable Java-based LDAP version 3 directory server. http://incubator.apache.org/directory/subprojects/eve/index.html. The University of Michigan LDAP mailing list LDAP at umich.edu. Mail list is a popular vendor neutral site used by LDAP developers and system administrators to resolve questions relating to the use of LDAP. You can subscribe to the mailing list using the following information: SMTP address, /dep-request@umich.edu. Subject is subscribe. Recent messages are arrived and can be accessed directly at http://listserver.itd.umich.edu/cgi-bin/lyrics.pl ? Visit =LDAP. The LDAP zone is a general purpose site dedicated to directory issues. It has a number of useful forums dealing with development and directory administration. http://www.ldapzone.com/ The Directory Interoperability Forum (DIF) is the open group's directory service related to working group focused on promotion of directory standards and standards comprehensive certification. http://www.opengroup.org/div/. The Mozilla site contains a number of LDAP SDKs that have been popular since the early days of LDAP development. These include the LDAP-C SDK, the Mozilla Java SDK, and Perl LDAP. http://www.mozilla.no.org/directory/net:/LDAP is a pure Perl LDAP module available from CPL. It is actively maintained and provided the most comprehensive set of capabilities for accessing LDAP directories via Perl. http://search.cpan.org/gbr slash Perl dash LDAP dash dot 31 slash. The Java naming directory interface GNDI is a standard component of Java. It provides the components required to build directory enabled applications in Java. http://java.sun.com /products/gndi/ The Active Directory Service Interface says ADSI provides Microsoft-based applications the ability to query and manipulate directories. http://www.microsoft.com/windows2000/techinfo/how-to-activate directory/ADSIL links a.hp. The directory mark is a benchmark marking suite designed to measure the performance of directory servers. http://www.mainframe.com/directory-market/index.html. The Java LDAP browser is a very good cross-platform pure Java LDAP browser editor. It is available for download at http://www.iit.edu/ga-ldap/index.html. JExplorer is another good cross-platform pure Java LDAP browser editor. It also includes very good support to SSL-based LDAP connections. http://pigacat.com/JExplorer/. Chapter 2: LDAP Concepts and Architecture. LDAP is based on the client-server model of distributed computing. The success of LDAP has been largely due to the following characteristics that make it simple to implement and use, compared to X.500 and DAP. This chapter explains the basic architecture of LDAP. It discusses the information, naming, functional, and security models that form the basis of the LDAP architecture. Various terms and concepts defined by or needed to understand the LDAP architecture are introduced along the way. After a general overview of the architecture, each of the models that form the backbone of the LDAP architecture is discussed in detail. 2.1 Overview of LDAP architecture. LDAP defines the content of messages exchanged between an LDAP client and an LDAP server. The messages specify the operations requested by the client, that is, search, modify, and delete. The responses from the server and the format of data carried in the messages. LDAP messages are carried over TCP/IP, a connection-oriented protocol. So there are also operations to establish and disconnect the session between the client and server. However, for the designer of an LDAP directory, it is not so much the structure of the message being sent and received over the wire that is of interest. What is important is the logical model that is defined by these messages and data types. How the directory is organized, what operations are possible, how information is protected, and so forth. The general interaction between an LDAP client and an LDAP server takes the following form. The client establishes a session with an LDAP server. This is known as binding to the server. The client specifies the host name or IP address and TCP/IP port number, whether the LDAP server is listening. Point 2. The client can provide the username and password to properly authenticate with the server, or the client can establish an anonymous session with default access rights. The client and server can also establish a session that uses thoroughly security methods such as encryption data. The client then performs operation on the directory data. LDAP offers both read and update capabilities. This allows directory information to be managed as well as queried. LDAP also supports searching the directory for data meeting arbitrary user-specified criteria. Searching is a very common operation in LDAP. The user can specify what part of the directory to search and what information to return. A search filter that uses Boolean conditions specifies what directory data matches the search. When the client is finished making requests, it closes the session with the server. This is also known as unbinding. The philosophy of the LDAP API is to keep simple things simple. This means that adding directory support to existing applications can be done with low overhead. Because LDAP was originally intended as a lightweight alternative to DAP for accessing X.500 directories, It follows an X.500 model. The directory stores and organizes data structures known as entries. A directory entry usually describes an object such as a person, device, a location, and so on. Each entry has a name called the distinguished name, DN, that uniquely identifies it. The DN consists of a sequence of parts called relative distinguished names. RDNs, much like a file name, consist of a path of directory names in many operating systems such as Unix and Windows. The entries can be arranged into a hierarchical tree-like structure based on their distinguished names. This tree of directory entries is called the directory information tree, DIT. Each entry contains one or more attributes that describe the entry. Each attribute has a type and value. For example, the directory entry for a person might have an attribute called telephone number. The syntax of the telephone number attribute would specify that the telephone number must be a string of numbers that can contain spaces and hyphens. The value of the attribute would be the person's telephone number, such as 512-555-1212. A directory entry describes some object. An object class is general description, sometimes called the template of an object, as opposed to the description of a particular object. For instance, the object class person has a surname attribute, whereas the object describing codes has a surname attribute with the value codes. The object classes that a directory server can store and the attributes they contain are described by schema. Schema defines what object classes are allowed where in the directory, what attributes they must contain, what attributes are optional, and the syntax of each attribute. For example, a schema could define a person object class. The person schema might require that the person have a certain name as an attribute that is a character string. Specify that an entry and person entry can optionally have a telephone number attribute that is a string of numbers with spaces and hyphens and so on. LDAP defines operations for accessing and modifying directory entries such as binding and unbinding, searching for entries, meeting user-specified criteria, adding an entry, deleting an entry, modifying an entry, modifying the distinguished name or relative distinguished name of an entry, move, comparing an entry. The version of LDAP all modern directory servers use today is LDAP version 3. LDAP version 3 is documented in several IETF RFCs. The key LDAP version 3 RFCs are listed below, along with a short description to provide an overview of the documents. Defining the LDAP architecture, RFC 2251 Lightweight Directory Access Protocol version 3 describes the LDAP protocol designed to provide lightweight access to directory supporting the X.500 model. The lightweight protocol is meant to be implementable in a resource constraint environments such as browsers and small desktop systems. This RFC is the core of the LDAP family of RFCs. It describes how entries are named with distinguished names, defines the format of messages exchanged between client and server, enumerates the operations that can be performed by the client, and specifies that data is represented using UTF-8 character encoding. The RFC specifies that the schema describing directory entries must themselves be readable, so that the client can determine what type of objects the directory server stores. It defines how the client can refer to another LDAP server if a server does not contain the requested information. It describes how individual operations can be extended using controls, and how additional operations can be defined using extensions. It also discusses how the clients can authenticate to servers and optionally use simple authentication and security layer, SASL, to allow additional authentication mechanisms. RFC 2252 Lightweight Directory Access Protocol version 3 Attribute Syntax Definitions. LDAP uses octet strings to represent the values of attributes for transmission in the LDAP protocol. This RFC defines how values such as integers, timestamps, mail addresses, and so on are represented. For example, the integer 123 is represented by a string 123. These definitions are called